Today we're going to be reviewing for our geometry test. Just going to go over some basic facts with you guys today. And first of all, let's make sure that we understand that our shapes are named for the amount of sides that they have, and then after that they're also named for the type of angles. So first, let's just look at your basic shapes. So any shape with 3 sides is going to be a triangle, right? That's pretty easy. A shape with 4 sides is going to be a quadrilateral. This quadrilateral happens to be a square. A shape with 5 sides is a pentagon. A shape with 6 sides is a hexagon. A shape with 7 sides is a heptagon. A shape with 8 sides is an octagon. A shape with 9 sides is a nonagon. Dun-dun-dun. And a shape with 10 sides is a decagon. And by the way, if you haven't already noticed, decagon, decade, a decade is 10 years, a decagon has 10 sides. All right, moving on. So now we name them by the number of their sides, but we also name them by the length of their sides and their angles. So there's all sorts of ways to be classifying shapes in geometry. So here we have regular polygons. Regular polygons are any polygon, triangle, quadrilateral, octagon, doesn't matter, where all the sides are the same length. An irregular or not regular polygon is a polygon where that it might be a quadrilateral, but its sides and angles are not all the same. So let's take a look here. So if we were to look at this one, I'm going to venture to guess, even though I don't have a ruler, that these sides look pretty much all the same and the angles look the same. So this one's going to be a regular polygon. I'm going to pull this one up here for a second, and I'm going to say these sides are definitely not the same. I don't need a ruler for that one. Now I'm going to look here. Now this is a triangle, but it looks to me to be a scalene triangle, so that would mean it is not regular. The sides are not the same length. Here's another easy one. This is definitely a not regular shape. It's a 1, 2, 3, 4, 5, 6. It's a hexagon though. Let's look at this guy here. 1, 2, 3, 4, 5, 6, 7, 8. So we have with us an octagon and all the sides look the same. So it's going to be a regular polygon. I think this is kind of cheating because if you haven't figured out, it looks like the shapes that are colored are regular and the shapes that are not are irregular. This one, definitely not a regular shape. All right, let's look at this one. 5 sides, all the same. And then we have an equilateral triangle. 3 sides, 3 angles, all the same. Awesome. Moving on. Types of angles. So the type of angle is important because the type of angle helps us classify shapes. It helps us classify triangles and it helps us classify quadrilaterals as well as many other shapes. So you have an acute angle. An acute angle is an angle that measures less than 90 degrees. So basically acute angle is like from 1 degree to 89 degrees, or even if you wanted to be technical, 89.9 degrees, okay? So it's smaller than a right angle. A right angle can only have one measurement. It is exactly 90 degrees and 90 degrees only. 90.5 degrees, it's obtuse. 89.5 degrees, it's acute. Okay, exactly 90 degrees. Now remember that this little thing here is super important, guys. If you see that, the person who drew the shape is telling you that it is a right angle. Okay, because a right angle makes a square corner. And then last but not least, we have obtuse. So an obtuse angle is going to go anywhere from 91, or actually 90.1, to 179 degrees, okay? Because an 180 degree angle is a straight line. So those are our types of angles. So this helps us classify shapes by knowing the types of angles that we have, okay? So that's going to become important. So let's see if we can label some of these angles here. So this angle here, now remember that we have our trick that we can use with a square, and you can do the same thing with an uncut piece of paper. So if I take my square and try to fit it right, put it right on the line of the angle and put the corner right into the corner, hey, look what I noticed. The angle is going through my square, which means that that is an acute triangle. All right? So this is nice when you don't have a protractor to measure, because let me tell you, hey, wait a minute, I don't need a square for this one. Look at this. It's telling me right here it is a right angle. So this is a right angle triangle. All right, let's use a square over here. I think it's kind of obvious, but I can just show you. You line it up there, right in the corner, and notice how it opens up past. Okay, if it was a right angle, it would go this way. Okay, but it's not going that way. It's bigger than my square. So this one is going to be obtuse. And then last but not least, this one pretty obviously looks to be acute to me, but again, you can do this with the corner of an uncut piece of paper. You take this little square. Now, this is nice because remember, you don't just put the square like this, okay? You have to take this square and you have to line it up with the bottom line of one of your angles. So I got to turn my square. Same thing with your paper. But notice that this still is going through my square, which means that that is an acute angle. All right. Again, this is important not just for naming angles, but for naming other shapes as we move forward. So this is a triangle, and a triangle that has two angles in it, by the way. So if I were to name this triangle, this would be a scalene obtuse triangle, because this right here is an obtuse angle, which I kind of gave away an answer. But right now it wants us to name the angles inside the triangle. So remember, we name angles by the letters. So if I went from here, y, to x to z, that would be one angle. If I went to x to z to y, that would be another angle. And if I went from z to y to x, that would be a different angle. So they want to look at the angle that goes x, y, z. Now, I already told you that that's obtuse. Okay, and now we want to start at x. We want to go to z, and we got to go to y. That one's going to be an acute angle. Okay, over here we have a pentagon. So remember our reminders here. The person who drew this shape is telling us that those are right angles. Okay, so that's going to help us out a little bit here. So we want to look for angle EFG. So I start with E, go to F, and then to G. And I know this doesn't look like a right angle, but if you were to take your computer and turn it so that one side was on the bottom, it would be easier to see. That's where the paper trick comes real in handy, or turning your page, because just because an angle is put in there crooked doesn't mean it's not a right angle. So that one's going to be right angle. It's got that little thing right in there. So, and then FEI. So F starts here, E starts here, I starts here. So if I were to use my little square trick, I'm very fond of my square trick, and I'm going to line it up with one line and right in the corner of my angle, and it's bigger than my square, so that is going to be an obtuse angle. All right, moving on. All right, so we also classify triangles by the length of their sides and their angles. So remember, each triangle can get two names, all right? So this is kind of really important. Equilateral triangle has all congruent or equal sides. An isosceles triangle has two congruent or equal sides, and a scalene triangle has no congruent or equal sides, because remember, congruent means absolutely the same. Okay, now you give it a name for its sides, and then you give it a name for its angle. So you have an acute triangle, has all sides. I'm sorry, this is a right triangle, my mistake. Let's skip over to this one for a second. Let's skip to acute triangle. And the reason I'm going to do this is because I'm going to match it to an equilateral triangle. So an acute triangle, all sides are less than 90 degrees. There's no 90-degree angle. There's no obtuse angle. The reason I wanted to point this out is because a equilateral triangle will always be an acute triangle. Always. Okay? Just, there you go. Then we have an isosceles triangle. Now you could have an isosceles obtuse triangle. You could have an isosceles acute triangle, and you could have an isosceles right triangle. What you have to look when you're naming your triangles is the angles. A right triangle has one 90-degree angle. An obtuse triangle has one angle bigger than 90. An acute triangle has all acute angles. So if we were going to name some triangles here based on angles and sides, I'm going to skip these top ones because this is getting kind of long. And remember what our little marks mean. okay? So these little marks mean that this side and this side is the same, and that this side is different. And this double arch there is they're going extra out of our way to let us know that that's an obtuse angle. But again, I could take my square. I could make that a little bit smaller. I could slide it right in there, line it up with the side of, oops, the angle I'm trying to measure. And oops, why does it keep doing that? And then drag it into the edge. And it is a little bit bigger than my square, so that is going to be an obtuse angle. Okay, so I'm going to call this one isosceles. We got to learn how to spell isosceles. Okay, the S is first. I know it's two S's and two E's. That's how I remember, because it has two sides the same. Isosceles, something like that. So this is an isosceles obtuse triangle. This one here, it has a right angle right there. It's telling us. And if you look, this has one line, this has two, and this has three. None of the sides are the same. So this one is a scalene right triangle. And last but not least, again, this one right here is showing us that it has a right angle in it. This side's the same, this side's the same. This has nothing, so it's not the same as anything. So we're going to come over here and we're going to call this one, again, another isosceles. They want me to learn how to spell isosceles, I guess. Isosceles right triangle. All right. And the last thing and slightly slightly tricky thing is quadrilaterals. And it is because quadrilaterals can fit underneath many categories. We just usually name them by the most restrictive category. That means if you were to start at the top and work your way down, what is the most, how far can your shape go? Okay, what is the most restrictive name you can give it? So if we're looking here, anything with four sides is quadrilateral. So any irregular shapes, even if they have four sides, are quadrilaterals. They're just not on here. A trapezoid only has one set of parallel lines, okay? So anything that has one set of parallel lines could be a trapezoid. Now, if you had a trapezoid that had two sets of parallel lines, well, you would have a parallelogram. So remember, parallel sides don't touch. So if those lines went on forever, they wouldn't touch. And if these lines went on forever, they wouldn't touch, even though my cursor made them funny. So look, those are all parallelograms. But then if we have a parallelogram that has four right angles, we have made a rectangle. If we have a parallelogram where all sides are the same, we can make a rhombus. If we have a rhombus that has four right angles, it now can be named a square. And if we have a rectangle where all the sides are the same, it is also a square. So what that means is a square can be called it fits in the rhombus category, it fits in the rectangle category, it fits in the parallelogram category, and it fits in the quadrilateral category. However, not all of those shapes can be squares. To be a square, it has to be quadrilateral with four sides the same, four right angles, and two sets of parallel sides. By the way, if it has four right angles, it's going to have two sets of parallel sides. There's no way around it. Okay, so a rhombus is a special type of parallelogram. So some parallelograms can be rhombuses. Some rhombuses can be squares. A square can be any of these things. Some parallelograms can be rectangles. All rectangles are parallelograms. Some rectangles can be squares, but all squares can be rectangles. All right, so let's name some shapes. Just really quick, because we're kind of stretching on time here. This one is a rectangle. It has four right angles. That's its most restrictive name, but it's also a parallelogram. I think let me make sure I spelled that right. Parallelogram. Looks like it. Okay. Now, it is not a rhombus because it does not have four sides that are the same, which means it also cannot be a square. But it's definitely quadrilateral. All right, let's check this one out. This one's, oops, that was not what I wanted. This shape has two sets of parallel sides, so it is a parallelogram. but it does not have 4 right angles, so it cannot be a rectangle. And it does not have 4 sides the same, so it cannot be a rhombus or square. It is a parallelogram and a quadrilateral. Now this one over here, this funky shape, oh, you know what? Could these all be trapezoids as well? They all have, if they have 2 sets of parallel sides, then they definitely have 1 set of parallel sides. So we could call it a trapezoid as well, which for some reason is a word I spell wrong. Trapezoid. So trapezoid. So it almost sounds like trape because it's got an E at the end of it. Okay. Which means that this has 1 set of parallel sides. And this one, which made me think that those ones could be called trapezoids, this one here, well, it only has 1 set of parallel sides, so it can't be a parallelogram. And if it's not a parallelogram, it can't be a square, a rhombus, or a rectangle, because those are all types of parallelograms. But it does have 1 set of parallel sides. So this side and this side, if you keep drawing them out forever, won't touch. But this side and this side, if they kept going, would touch around here somewhere. So this is a trapezoid. And obviously a quadrilateral. By the way, none of these shapes are regular quadrilaterals because they don't have all sides the same. So the only regular quadrilateral would be a square.